All right, Mathletes, welcome back to another episode of Math with Dr. Math. Today, we're going to be looking at the standard normal curve. All right, so before we dive in, let me kind of explain what this is used for. So let's take this number right here, the one I'm pointing at, the 2.11. All right, and when we talk about the standard normal curve, few points. We know that everything, right, that total probability under that curve is always 1, right, which translates to 100%. In this case, when I look at standard deviations, what we're going to be able to say is, what percent, what's the probability, right, what percent of the population falls less than whatever number we're looking at. In this case, these numbers that we're looking at represent standard deviations. Okay, so the original problem looks something like this, right? So here's an example of our standard normal curve. All right, it's not the best. So 0 is always, when we're talking about standard normal curve, 0 is always smack in the middle. All right, and in this case, the number of interest, the standard deviation that we're looking at is 2.11. So the program that I'm going to introduce you to does a whole lot of things. All right. So one thing we could look at is what's the probability, right? What percent of the population falls less than 2.11? That's one question that the calculator can answer for us. In this particular problem, part 1, what they're interested in is, let me shade this in red. What's the probability, or what's the percentage of the population that is greater than 2.11 standard deviations? All right. So we're going to be doing a lot of translations through this chapter here. But ultimately, what we're trying to find is these percentages. What percent of the population falls less than or greater than some particular value. That's what we're going to be looking at. And what I'm going to be walking you through is how to use our TI-84 calculator to help us get these percentages, these probabilities. All right, so let's look at this one. So notice for this particular problem, they wanted us to find the area to the right of 2.11. All right, so let me flip the camera on you, and what we're going to look at is how to do this using our calculator. All right, so here we have the TI-84 calculator, and I want to thank my friends over there at TI for sponsoring this video and providing us with this calculator. I'm just messing. So what we do to get to the program, we hit second and vars, and that's going to get us into that distribution. So again, I hit second, that blue, and then vars. All right, and what we want here is we want to use normal CDF, which is that second choice. So let me go down, to normal CDF there, and go ahead and hit enter, press the number 2, and they're going to want our lower and our upper. So let me kind of redraw this distribution for you. Let me kind of shrink my screen and put this over here. So this is where we really have to understand what our calculator wants. So when we draw this distribution, right, so there's my distribution, and I'm looking at 2.11, and in this particular problem, I want everything to the right, okay? So the smallest number that I'm interested in, this lower bound, is 2.11. So that's our lower bound here. So let's go ahead and enter 2.11. And for the upper notice, this everything is shaded to the right, so we don't know how far this is. So what we do is we get really extreme. We put a humongous number just to make sure we include everything over here shaded. So what we do is we hit 1, and notice I have the EE button. So I'm going to hit blue, which is second, EE, and then I'm going to put 99. So whenever we want to shade everything to the right, that's what we're going to use right there. 1E99. 0.99. All right. And because we're dealing with a standard normal curve, your mean is always 0 and the standard deviation is always 1. Never change those two. And again, that only works when you're dealing with a standard normal curve, just like we're doing. All right. If your calculator doesn't have this nice function that you see here, you might, let me hit enter. Some of your calculators, if you're going old school, just gives you normal CDF and you have to manually put all this in. So just remember, the first one's the left value, the right value, the mean, and the standard deviation. So it's the same exact thing, except you're going to have to manually enter those numbers in. All right, so once I hit enter, let me go ahead and enter. I get the probability, and we're going to round this to 4 decimal places. So we get let me get a pen, 0.0174, because we rounded to 4 decimal places. So this right here represents that area that's right there. And when I use a real graph, notice I just did a quick sketch right here. But when I actually use a drawing that's to scale, what we're going to see is that this area that's represented here is going to be very small. So that makes sense that this is a very small number. So we're right on track in terms of what we wanted. All right, so let's do another example here for you. All right, for question 2 here, now they want this probability, right? This percentage of everything that's less than negative 0.38. So what I did is I gave you a better representation down here, a better graph of where this actually is. So let me draw that out for you. So if I were to choose where negative 0.38 is, that's going to be somewhere like right here. And I'm looking for everything shaded to the left, right? So I could see that when I use a calculator, this left bound is going to be this negative number over here, right? Because this is getting shaded all the way that way. And the biggest number is negative 0.38, right? This is where it stops. So when I use that program, normal CDF, that we're going to look at right now, the left point here, I'm going to use negative 1E99. And this is what you're always going to use when everything's shaded to the left, right? When everything's shaded to the left. If everything was shaded to the right, then that would be a positive. So just make a note of that. That's going to be very important. When it says the rightmost point, you always go from, right? You always go from left to right. So you ask yourself, okay, when moving to the right, from left to right, where do I stop shading? I stop shading, boom, right here at negative 0.38. And of course, our mean is always 0 because we're talking about standard normal curve, and our standard deviation is 1. All right, so let's go ahead and do some calculator work. Let me flip this guy around. All right, look at this calculator. Again, I hit second distribution, and I'm going to number 2, normal CDF. We set our lower limit, excuse me. The lower limit is what? Good, negative 1E99. So I hit negative, and make sure you actually use the negative button. Don't use the minus. Do not use the minus. Use the negative. All right, so negative. Sorry, I gotta get a better stand. 1 second E99. All right. Let me scroll down. Our upper we said is negative 0.38, and then our mean and our standard deviation is good. All right. So let me scroll down. Hit enter. Boom. So everything's exactly like we want it. And so there is our probability. So this area, let me kind of see if I can move this. This area that I have in blue here is 0.3520, because notice the number they gave us, 0.35197. But we want to round to the nearest 4 decimal places. So this 7 is going to kick that. Think of it as 19. This 7 kicks the 19 up to 20. Think of it that way. So this is going to be the probability that's associated with this shaded area. All right. And pretty soon we're going to make sense of what did we actually find. Right now we're just showing you how to navigate, these graphs, but they're all going to represent something real very soon here. All right. So let me know if you have questions. And in my next video, what we're going to be doing is we're going to be going backwards. I'm going to give you a shaded area, and I'm going to tell you what the shaded area is in the next video. And then what I'm going to have you do is find these z-scores, these standard deviations. All right, so we're going to be going backwards pretty soon. All right, if you have questions, make sure you comment down below. Let me know how things are going, and I'll talk to you soon.